Hello guys, welcome back to our new video, and in this video I am going to discuss about the Linux LVM with the kitchen masala box strategy. So this is very simple to understand LVM, and this is my own method to explain the LVM, and I hope you will enjoy this video. So without further wasting any time, let's start. So this is the agenda of today. So first of all, we are going to discuss what is LVM in Linux. Okay, then we are going to discuss why we need LVM. Okay, and then understanding the LVM architecture. I will show you the traditional architecture and also my architecture. Means with the kitchen masala box architecture, we will understand what is LVM. And then fourth number agenda is creating logical volume. There I will show you on my lab part. Okay, on my computer virtual machine. There I will show how to create LVM and all those commands and how to create step-by-step procedure. We will follow there, and at the end we will mount it. That's all about today. So let's start. So first of all, your question is what is LVM, right? There are different types of partition you can create. First of all, in Linux there is standard partition like disk partition, primary partition, external partition, logical partition. But you know, the real-time problem of those partition is actually we cannot increase or decrease the size of the partition. Okay, and it is really very difficult to increase or decrease. I will not tell it is not possible. It is possible with some tool, but it is really very difficult to manage. So logical volume manager is a concept which actually have all those components where it will help you to extend, reduce, or maybe create a logical volume or take a backup of the existing volume. Okay, move from one system to another system. Those tasks you can easily do it with a logical volume manager. Okay, this is very big and also very important also. So LVM or logical volume management is a storage device management technology that gives user the power to pull and abstract the physical layer power to pull and abstract the physical layout of component storage devices for easier and flexible administration. What does it mean? Actually, logical volume manager gives you the power to pull and abstract the physical layout. Means physically we have a partition, right? Or maybe you have a hard drive. That hard drive will be attached to your system, right? This hard drive will come to your system like SDA, SDB or something else. Like if you are working on virtual machine, it will come like VDA, VDB. So that's fine. This is the main resource to create a LVM. Okay, so first of all we need a partition or we need a block device, then only we can create a LVM. So this is the resource needed to create the LVM. So but when we will create the LVM, what is the main advantage you will get? The main advantage is that we can easily move the volume from one devices to another, one node to another, and also we can easily resize them, we can easily abstract them, we can easily increase the size of the LVM. Okay, every task you need you can easily do, even you can take a snapshot also. Okay, that is the thing. So flexible administration, this will help you for flexible administration. Okay, so you don't need to worry about storage and anything. In SAN storage area, in RAID, there most probably LVM they are using to manage their big storage. Okay, now why LVM? LVM is very important, and in every area we normally use LVM. Okay, and even if you are using LVM in your system, that is also very helpful. When you are installing a OS inside your system, definitely you should use the LVM, because later you can increase the size, right? If you have selected the standard partition like primary partition or external partition, it will be very difficult later if you want to increase the size of slash or something. Okay, so better if you are individually doing it inside your laptop, then also it's very important to know LVM. The main advantages of LVM is it can be resized dynamically as space requires change. Okay, means if you need, you can easily resize. You can easily extract some storage space from that volume, or you can attach if it is needed. Some spaces may be needed. You can increase the size. Okay, it doesn't matter, and even you will not lost your data if you decrease the size. Okay, I'll show you on the next video. I am coming up with a resizing of LVM topics. Okay, be updated. I'll definitely come up with the new video. So in this session we are going to discuss only how to create the LVM, but on the very next video I am going to discuss how to resize LVM. Then we will discuss if you are using different file system like ext1 to 234 or xfs, or what is the different method to extend or reduce the size of LVM. There we'll discuss, even we will take a snapshot of it, how to restore it, all those things we'll discuss. But today we are going to discuss how to create LVM and why LVM. Resizing actually is the main purpose of LVM, means it gives you the flexibility to resize the storage space. Okay, and this is really needed in our environment. Okay, we don't know how much space later we need. Today we can start a company with a maybe 1000 GB or 1000 GB of data. Maybe today you have created your flash partition with 20 GB of data. Okay, 20 GB of size. Later you may need some more spaces, but if you have used a primary partition, there will be difficulties to increase the size. Okay, you need to think about a different method or different things, or maybe you need to again reinstall. So that's the problem we are facing. So to overcome this problem, the next level storage administration tool is LVM. With the help of LVM, what you cannot do, everything you can do. Even if you want to move your data from one computer to another computer, that also is very possible, very easily you can do. Okay, so as space requirement change and migrated between physical devices within the pool on a running system or exported easily, so you can easily export from one system to another. So LVM also offers advanced feature like snapshotting, stripping and mirroring. That is also possible through LVM. Okay, so there are many advantages. So now let's move on to the next thing, that is the LVM architecture as per the traditional method. This is a traditional architecture of LVM. So first of all, I told you need a partition. Okay, partition can be primary partition can be a logical partition. Logical means it's not a LVM logical, it's a normal logical partition what we create normally. If you have the idea of extended partition, inside extended partition we normally create the logical partition. So that type of logical partition I am talking. Okay, you need a logical partition, or maybe you need a primary partition, or you can use the whole disk. Okay, you can use the whole disk, means you are not creating any partition, directly you are attaching it as a PV. That is also possible. So first of all, the resource we need, that is your hard drive. So hard drive, we can attach the whole hard drive, or else we can create a partition on it and then we can attach it. Okay, so the first line you are seeing here, dev sdb, dev sdc, dev sdd, so those are actually the hard drive. Okay, they have attached this hard drive on the very next level, that is PV, physical volume. So what is physical volume? Physical volume actually is the initialization of a LVM. Okay, means here we are initializing. So what we are doing here, we are actually initializing the LVM. Okay, means this partition, this drive actually is going to be created as a LVM partition. Okay, that we are initializing, adding it in the PV, physical volume. Okay, now the next step we can move. Okay, so if you have not attached this PV, we cannot further move on to it. Okay, so definitely we need to add it inside our physical volume. So when it is initialized as per the LVM method, so when it is initialized as a physical volume, then we can easily move on to the next part. The next part, the third number thing you can see, third line, that is volume group. So what is volume group? Volume group is very important here. Actually in physical, on the previous level, what we did, we actually initialized, we have labeled that this partition is going to be created as LVM, but on volume group we actually divide the whole partition into small chunks. Okay, the small pieces, why we are dividing it into small pieces? Okay, because maybe you have 200 GB of data and you are creating a small chunks of 100 MB. Okay, so 200 GB will be divided into 100 GB, 100 MB, 100 MB, 100 MB, like that, small pieces. Okay, now you have a number of pieces. Okay, from this number of pieces, you are taking how many? So maybe you are taking 100 number of PV. So whole thing we actually will discuss on the kitchen masala box strategy. Here just you see in VG, if I describe here, you will not understand properly. So let me describe it there. So the step you can easily see. First of all, physical device we need, then we have to initialize it as the physical volume. Then we'll actually make a small pieces inside the volume group. Okay, so we will get a number of pieces there. Okay, you may have 200 GB. This 200 GB will be broken down into small pieces. So you will have a specific number of pieces. You can increase the number of pieces. How? Attaching a new hard drive to this volume group. Okay, you can create multiple volume group also from one physical volume. That is also possible. After getting the volume group, now from that number of pieces you take a smaller number of pieces. Maybe you have 2000 number of pieces, 2000 number of chunks. From these chunks you are maybe taking 100 chunks, or maybe 100 pieces. With 100 pieces you are creating a logical volume. So this logical volume actually taken from the volume group. So volume group having lots of chunks, lots of pieces. From this chunks we are taking only some chunks. Yeah, and you can also increase the size, adding some chunks from that volume group to your logical volume. Okay, and also you can reduce the size when you are removing it from the logical volume to the volume group, so it will be separated. We can easily do it. So when the logical volume is created, the fourth number field, what you are saying, when it is created, then you can store your data. You can easily store your data, but to store data you need to definitely format your hold storage space. Okay, without formatting, you know that we cannot store the data. So you can use any of the formatting style like H22, H23, 4 and XFS. So after formatting it, then you can easily store it, store the data, but you have to mount it. So after mounting it you can do it. So you need to mount. So those tasks will do here. So in this picture I have not tried to go into deep dive in this architecture. I'll go into deep dive on the kitchen masala box strategy. Now you need to know what is volume group, what is physical volume, what is physical block device, what is logical volume. Those things let us discuss, then we'll move on to a deep dive on the LVM architecture. Just a few things I have told you here, again we'll come to here. Okay, so what is PD first? PD means physical devices. That is the main resources we need. You can use RAID, you can use SAN, you can use hard drive. Hard drive means normally what is connected to your laptop or your computer. So anywhere else you can implement this LVM. Okay, but how we can do it, and why what is the physical devices? So physical devices are the storage devices used to save data stored in a logical volume. So data actually will be stored on the physical hard drive, right? We are storing it logically in this partition, in this drive, in this folder, or there, but at the end it is going to be stored on the physical devices. Like it can be hard drive, it can be SAN, it can be RAID. Okay, so these are the block devices and could be disk partition, whole disk, RAID arrays, or SAN disk, what I have told. So a device must be initialized as an LVM physical volume in order to be used with LVM. Okay, so a device we definitely need, otherwise how can we store the data? So this is the first thing we need to attach to our system. The entire device will be used as a physical volume. Then the whole device we can we can attach to our system. We can create LVM on the top of this physical devices. Okay, that is all about physical device. Now the next part comes PV, physical volume. Okay, now move on to the physical volume. So what is physical volume? You must initialize a device as a physical volume before using it in an LVM system. Okay, it means what? So we are going to create a partition, or we are going to create a LVM. We need to initialize first, otherwise our system will not understand. Okay, so this is the first step we need to do. First step is you initialize the existing physical device or the partition as a LVM. Okay, then LVM tools segment physical volumes into physical extent, which are small chunks of data that act as a smallest storage block on a physical volume. Okay, so LVM tool segment the physical volume is what? This physical volume will be again divided into small chunks. Okay, and the data will be stored on these small chunks. So this is the physical volume. So adding it will not actually broke down into small pieces. When you create the volume group, then only it is divided. Okay, so when we are initializing our device, means the physical device into the physical volume, Don't think that it is divided into small chunks. It will be divided, but when you will create the volume group, then only I will show you on the lab part also that when we have initialized the physical volume, it is not divided into small chunks. It will be divided when volume group I will create. Okay, so next part is volume group. So volume group is what? Volume group are storage pools made of one or more physical volume. So what you can do, maybe you have different partitions, 4 to 5 partition, or maybe you have multiple hard drives. Okay, so those hard drives or a partition you can easily attach to your physical volume, right? We can add it to your, you can initialize it as a physical volume. Then you can attach those physical volume into your single volume group, or you can create multiple volume group with those PV. Let me repeat again. You can attach some partition or some storage physical devices into your system. Okay, you can initialize them to your PV. Now inside your PV, maybe you have different partition you have initialized, or maybe different devices you have as VDA, VDB, or maybe VDC, or maybe partition 1, partition 2, partition, many things you have added. So all of those things you can add it to a single volume group. You can create a single volume group with those things, or else you can add a different volume group. You can create different volume group and give some of the partition to a volume group number 1 and give some of the partition to volume group number 2. We can do it, but when you are creating the volume group, you can actually mention the small chunk size. What would be the size of the small chunks? Okay, normally the size is 4 MB, but you can change the size. Okay, and also at the time of creation you can tell what will be the size of the small chunks. Okay, means so when it is going to be broken down into small pieces, so what would be the size of each small pieces? If you don't mention, the size will be 4 MB only. But if you are going to take 10 MB, you can do it. I'll show you how to do it. So this is volume group. Okay, means we are grouping multiple physical volume into one volume. This is the functional equivalent of whole disk in basic storage. A PV can only be allocated to a single VG. A VG can consist of unused space and any number of logical volume. Okay, a VG can consist of unused space. Okay, so VG normally there is no data right now. After creating VG, we need to create logical volume. After the logical volume, we need to mount format mount, then only you can store data. So right now we are just going step by step. We're not going to store in data, and it doesn't mean that you have created volume group and now your system is your volume group can store the data. No, you cannot store data directly to your volume group. You have to create the logical volume, then only you can utilize it. Okay, hope you are clear with that. Now the last and the end thing is logical volume. What we are going to create, means this is the end thing where our goal is to create LVM, means logical volume. But to create this LVM, few steps we have seen. Those steps you have to follow. First you should have the physical device, then add it as a PV, then create the VG. Now you will get the LV. So logical volume are created from free physical extent. So what is physical extent? Physical extent actually the small chunks. The small chunks is called as physical extent. Okay, and it is inside the volume group. When you created the volume group, your PV is divided into small chunks. This chunks is called as physical extent. Okay, each chunks is called as physical extent. Okay, it is divided into your volume group, so you can see it inside your volume group, and also you can see it inside your PV. Okay, and provide the storage device used by application, user, and operating system. So now this physical extent, you will store data. Who will store the data? Maybe some application, maybe some user, maybe the operating system will store the data inside your physical extent. Okay, but when you are creating LV, you will take some number of P, means physical extent, from that volume group, right? Maybe you have 3000 number of physical extent. You have 3000 number of small pieces. Physical extent means the small pieces. So 3000, but you are not taking 3000. You are taking maybe 1000, and each chunk size is only 4 MB. So 4 MB into 1000, how many? Okay, now you count. So this many storage space you have taken is as a LVM volume, logical volume. So rest of the thing are remaining inside your volume group, right? So you can later add them, but right now you have taken only 1000. So when you have taken this 1000, This will be called as logical extent. So LV are a collection of logical extent. So same thing, the chunks, it is also a chunks, same chunks, but when you have separated, when you have isolated them to store the data to create the LVM, logical volume, this will be called as LE, because this thing, we are going to store our data inside a logical volume, not inside the volume group, what is remaining inside the volume group. Okay, from the 3000 pieces we have taken only 1000, and this 1000 physical extent now will be called as LE, logical extent, when we have taken inside the logical volume. Okay, so physical extent and logical extent, there is no difference, just a name in different environment. When it is inside volume group, we will call it as physical extent. When it is inside logical volume, we will call it as a logical extent. Okay, which map to physical extent. Actually, physical extent same thing. Okay, and the smallest storage chunks of a PV. By default, each LE maps to one P. Means same thing. LE and P size would be same. Okay, so actually the LE means what? LE means isolated physical extent from the volume group, where we are going to store our data. Where with how many P you have created the logical volume, those LEs, those P will be called as LE. So they actually are mapped to a particular P, physical extent. Okay, setting specific logical volume option changes this mapping. For example, mirroring causes each LE to map two P's. Okay, mirroring is a different concept. There we can do those things. So later we'll discuss those. First of all, you need to know that each P and each P and LE size is same here, and we both will be mapped. Okay, and there is no such difference in size, and they're same thing but on a different level. Okay, this is the LVM architecture. Now we are going to learn through the kitchen masala box strategy. So first of all, you see what you are seeing. First of all, you are seeing this is the room, right? This is your home. Inside your home, what you have. So this is your home. Inside your home, you have different rooms. Maybe this room number 1, room number 2, room number 3. Okay, room 3. The down here. This is another room. This is another room. This is another room. So room are called as PV. Okay, room are called as PV. But the home will be called as home, means disk partition. You can see on the right side top. Home is disk partition. Your room is what? Your room is, here it is written, your room is what? Kitchen, physical volume. This is kitchen. We can add this one also as a kitchen. Okay, so this is the kitchen. Inside the kitchen, what you have? You have a masala box, right? Inside this masala box, we store different type of spaces. Okay, so inside the masala box, we naturally store different type of spices. So this masala box, inside one masala box, what we have? We can have multiple small boxes, right? There can be 5, there can be 10, there can be 15 boxes. Okay, now inside your kitchen, this I am taking this room only. So this room is what? This room means you have initialized your physical device as a PV. So this yellow colored boxes you are watching here, that is your volume group. Okay, but this is same. When you have initialized it, it is called as physical volume. Okay, physical volume. Dekho, this yellow box is physical volume, but when you have created the volume group, means you have divided it into small things. So okay, so this is your physical volume, and physical volume means there will be no such division, means there will be no such pieces. There will be one single device. Okay, one single volume. But when you have created a volume group, now the next step is volume group. When we have created a volume group, it will be divided into small chunks. These are all our black spot you are getting, black small boxes. Those are the chunks. Now this small one pieces is called as P, physical extent. Okay, this one piece will be called as physical extent. But physical extent, there are many physical extent, right? In masala box also, we have multiple boxes, but we are not going to use all of the boxes. Maybe I have 15 boxes inside one masala box, but I have only 5 spices. So how many boxes I will use? I will use only 5, right? Same thing happens here. So actually what you are utilizing only 5 boxes. So same thing, from this number of box I am using only this red line, you are getting red box, I am using only these many boxes. So these many boxes I have separated, I have isolated. So these many boxes will be called as LV, okay, logical volume. So masala you are storing means the data. We are going to store our data inside this logical volume, that is LE. So one small piece of chunks will be called as logical extent. When it was on the physical layer or volume group layer, it was called as physical extent, but now it will be called as logical extent. But the same thing, okay, they are mapped. Physical extent and logical extent are mapped here. So that is the strategy. Means inside your room, the room is actually a kitchen, and that is your PV, physical volume. And inside your physical volume, you are purchasing a masala box. That masala box is actually your volume group. In masala box, you have multiple boxes. Okay, the box number can be 20, 55, anything else, and the box size can also vary, right? Box size can be smaller, can be bigger, can be medium size, anything else. You can also change it here. Okay, so that is a part of volume group. And at the end, we are going to store our spices on that box. But I am not using all of the boxes. You can use all of the boxes. Maybe you have only 5 boxes there inside your whole masala box. So you are going to utilize all of those. But maybe you have 20. So I don't know you are going to store 20 masala or not. But you can store. But normally I am taking 5. So when you have separated these 5 boxes, means you are storing some spices on these 5 boxes. These 5 boxes are your LV. Okay, and they will be called as logical extent. And the remaining free boxes where you have not stored any spices, that will be called as your physical extent, and there we are not going to store any data. Until you initialize them inside your logical volume, you cannot store data there. Okay, that is the thing. That is the whole architecture. So the step we are going to tell here. Step means first we need to create a partition or use a whole disk. Okay, so then only we can do it. So what are the next step? Next step is initialize it as a PV. So if you add the partition or add the whole disk into your physical volume, then you can create your volume group. When you are creating the volume group, you have to provide a name to your volume group, definitely, and you can also tell the size of each small chunks, each physical extent, each physical masala boxes. Okay, you can tell the size. Normally if you don't tell the size, it is going to be take 4 MB, and one box it will utilize to store the metadata. So always remember, if you have 200, if you have divided into 200 boxes, so you will get only 199 boxes. Okay, one boxes it will use for metadata, storing the metadata. Okay, next step, when you have created volume group, create the logical volume with say specific number of PE taking from the volume group. Then the next step is format the logical volume. You know that without formatting we cannot store data, so formatting is very important. So after that we are going to mount it. So we'll mount it permanently, and then I'll tell you how you can store the data. Okay, that is the whole step. Now let me move on to our lab. So friends, I have opened my lab here. Here I am going to show you how to create the LVM. Okay, this is my host OS. Here I have a virtual machine. That machine, let me connect it with the SSH. So that is server A. Here I have a block device here available, LBLK. So how to check your block device? You can use the LBLK command to check. Okay, so I have VDA. In VDA you can see I have one partition only, that is the primary partition, and here whole OS is stored. So the size of this VDA is 10 GB, and whole 10 GB is utilized. So I cannot create multiple partition here. All storage space are utilized. But VDB, that is a block device. There I have not created any partition, and 5 GB is remaining there. So you can add the whole disk into this, or else you can create a partition here. Okay, so I'll do what? I'll create different partition and I'll attach them. Okay, so first of all, how to create a partition? We are going to create a primary partition. Okay, hope you know that. So fdisk command I am going to take dev vdb. Okay, so remember we are creating here DOS disk level, means MBR partition we are going to create. Okay, now new partition. To create a new partition, N. Now it is giving you the option 4 are free. So you know maximum 4 primary partition you can create. So I'll take primary. Take primary number. I'm taking the default number. First sector leave it for metadata. Last sector please put a plus sign. I'm taking only 1 GB from this 5 GB. Okay, I have taken. Now one thing, it is not mandatory part what I am going to show here, but you can do it. You can label that partition that it is going to create, going to be created as a LVM. So you can change the code for this volume. Okay, so you can press L to list out all things. Here you will get 8E. Okay, 8E, search it. 80 for LVM actually. Okay, so let me show it. Swap. Where is 80? Okay, I'm unable to search. Yeah, here you see 80. Here we will get a number 80. This 80 number is actually if you set 80 number, it will be labeled as LVM Linux LVM. So I'm giving 8E. Okay, small e. Now if you do run p command, then it will show you 1 GB partition you have created inside the VDB. Then the size is 1 GB and the type is Linux LVM. Now if you press W, it will be set. Okay, I'll create one more partition. Let's see it again. New partition, primary partition, number 2, leave the first sector, add 1 more GB to it. Okay, toggle. Here I am not initializing as a LVM. There is no worry, I told you, right? You can add it, so you can change the code or else leave it as Linux. Okay, don't need to worry. Okay, now LSBLK, you check it, your VDB1 and VDB2 is attached. If it is not attached here, if it is not coming, you can run a command part pro. Okay, so it will be updated to your kernel. Now if it is not coming, you run this command. Okay, now it is coming here, so I have not to worry. So this 2 partition I have created. Okay, this is my physical devices. Okay, next step, we need to initialize it as a physical volume. Okay, so how to create a physical volume? PV create. PV create is to create a PV. PV create dev VDB1. Okay, next is VDB2. So both the partition what I have created, I have initialized it as a PV. Now you can display it. So PVS. PVS will show you how many partition you have initialized as a PV. Okay, this is VDB1, VDB2, 1 GB, 1 GB partition I have taken. Now you can attach more, but I will not attach more. Leave it here. So you can display in a different way also. Let me tell, PV display. Okay, that is also a command. So here what you will get, this is the full and long details of the particular device. Okay, that is VDB1 and VDB2. Now you see one thing I told you on the PPT, that I'll tell you now, when you initialize a physical volume, it is not divided into small chunks. So total number of P physical extent you are getting 0. It is not divided. Okay, it is not divided, and unique ID also given to it. Okay, so both the partition, it is not divided up to now. It will be divided when I will create the volume group. Okay, so now see what happens. So how to create a volume group? VG create. Now the name of volume group name I am giving here Red Hat. Okay, dev VDB1, dev VDB2. Both of the partition I am adding it to Red Hat volume group. Successfully added. VGS you run. So I have created single volume group with this 2 partition. Means this volume group size will be what? 2 GB. So you are getting here, this is like 1.99 GB something, around 2 GB. Okay, so there is 2 PV. 2 PV means 2 PV I have added, VDB1 and VDB2. So this 2 PV attached to Red Hat volume group. It is divided now. I told you, when you create a volume group, definitely if you are not assigning the size of each chunks, it takes 4 MB. How to check it? VG display command you can run. If you run the VG display, it will give you long details. Okay, this is the long details. Here the volume group name is Red Hat. This is, there are actually metadata 2, and then you can see lots of details are here. Current PV is number 2, 2 PV is attached here, and this is the whole size of volume group, and P size is 4 MB. I told you the PV size you will get, sorry, P size you will get 4 MB. So 4 MB is the P size, physical extent size. Okay, I have got total number of P, that is the 510 number of P I have got. So from this number of P, I can take 100 number of P. 100 into 4 means 400 MB of data. 400 MB logical partition you can create later. So we'll discuss that. So now we are going to create the logical volume, but before that let me show you. I told you here it is not divided, but now when I created the volume grid, it will be divided. So let me verify it. PV display. Okay. Before that, if you see here, before that I showed you, here, there was no number of P, 0. But right now when I have created the volume group, we are getting there is 255 number of P. 255 number of P. Why this is to be there? Because for each and every partition, this will be different, right? Total number I have got 510 because they two are attached to volume group Red Hat. So here also you are getting the P size 4 MB and 255 number of P I have got. Okay, so they are divided when you create the volume group. Now the next part is to create the logical volume. Okay guys, okay friends, so we have created the PV and VG. Now we are going to create the logical volume. So PVS you can see we have created, VGS also we have created. Now we are going to create LV. So LV create is the command to create LV. Now you need to mention the number of PE you are going to take to create the LV, or else you can mention the size. Okay, so what the size we have? We have 1.99 GB. From that size you can take maybe 1 GB, or you can take the whole size, or you can take 1.5, else anything else. Or we have got 500 number of P. How to check? VG display. Okay, VG display. Sorry, VG display. Here you see we have got total 510 number of P, and all are free right now. There is no allocated P up to now. So you can take 100 P. 100 P if you take, you are going to get 400 MB like that. Okay, so LV create hyphen, if you use small l, you have to tell the number of P you are going to take. So how many number? I am taking 100 number of P. Okay, 100 number of P, and here you have to provide a name. Name I am giving it Fedora. Okay, the volume group name is Red Hat and it is Fedora, but it is inside Red Hat volume group, right? That is your LVS, you see it. Now you have got 400 MB. So I have mentioned 100 number of P. Each P size is 4 MB. So 4 into 100, how many? 400. Okay, 400. Understood? One more thing, that is, if you want to increase it, you can also assign some more PV to it. But it is very easy to increase the number of P up to now here. But when it is formatted, it is very difficult. So there is something you need to know. On the next video we will discuss that. Okay, so this is my LV display. If you run this command, you will see a long details of that. So my LVM path is dev Red Hat Fedora. Okay, dev Red Hat Fedora. LV name is this, volume group name is this. This is the UUID, and that is my server, and that is LV size. So current LE is how many? 100. Okay, 100 LE I have. Now how can we store the data inside the LV? So we have to format it, but to which device will format? But if I tell from the starting, I have created a partition VDB, sorry, this one I have created, right? So VDB1, VDB2, like that. Okay, so 400 MB of partition is created inside this. So you will not mention this partition as a path. Okay, you have to follow which path? You have to follow this path. Okay, dev Red Hat Fedora. So you'll format this device. This is your new device. Your new device is dev Red Hat Fedora. Now you'll not mention dev VDB Red Hat Fedora, not like that. You forget about your partition. Now you mention this device. This is your new device. Okay, when you have created LVM. So how to format? You know, mkfs dot I'm doing it with XFS, then dev red hat fedora. Okay, it is formatted. How to check, how to verify it is formatted or not? BLK ID command you can run. When it is formatted, one specific ID will be given to it. So you can see it went to dev mapper. Okay, I have mentioned only dev red hat fedora, but it directly goes to this path. Why? Because all logical partition by default in Linux comes to dev mapper, inside mapper. Okay, and this is the UUID of it, and this is the type is accepted. It is formatted. Now it is ready to store the data, but to do it I have to mount it. So let us create a mount point first, mkdir slash LVM. The mount point I have created LVM. Okay, there I am going to store the data, but I'll mount it permanently. Vim slash etc fs star. You can mount it taking the UUID, or else you can use the path. Okay, there is no such issues if you take one of them. Okay, I am taking okay, let's take the path. Okay, so vim slash etc fs tab. Okay, here come down and write down. I am not taking the UID. Let us do it with the path. Dev red hat is volume group, and fedora is your LVM. Okay, logical volume. Never mention the partition. Partition means VDA or VDB or SDA, SDB if you have. Never mention that. Don't do this mistake. Okay, when you create a logical volume, you get a new device. The new device is your dev, your volume group, and then your logical volume. Okay, the next field is your mount point. Okay, our mount point is LVM. Then your file system is XML. Then default. I have no such option, so default. Then your FSCK and back 00. Okay, WQ. Then some mount -a command is very important. So mount -a command you need to run, then only it will be updated on DFF and TH command, and also it is going to tell you if you have any syntax error on the FSTF file. Okay, after running this mount -a, you can run DFF and TH. Now it will show your LVM is successfully mounted. 395 MB is free. Okay, and this is your LVM file. Okay, that is all about LVM. Hope you have enjoyed it. Okay, I'm coming up. Hope you have enjoyed it. I'm coming up with a new video. There I'm going to discuss LVM resizing. You know, the very important part and the most difficult part is not to create LVM. The difficult part is to resize LVM. So on the next video we'll go a deep dive into that resizing part. Okay, so be updated soon. Maybe on the next week I'm coming up with the new video. So thanks for watching, guys. Please don't forget to like and subscribe. Comment me if you have any questions. Okay, down there I'll definitely reply.